Good day all of you. Today's gate question is, the H parameter of a two-port network are shown below. The condition for the maximum small signal voltage gain V out by Vs is, this is a circuit given, H parameter model of a two-port network. For this circuit, you have to find the condition at which the small signal voltage gain V out by Vs is maximum. Okay, these are the options given. First, we'll see what is V out by Vs. Is the maximum small signal voltage gain. Yes, the voltage gain AV, voltage gain AV is equal to V out by Vs. Okay, so now we'll see what is V out. See here carefully. Output side, we have two components. Yes, the voltage here is at this port, and we know this is the port 1 and this is the port 2. At port 1 we have voltage V1 and at port 2 we have voltage V2. Now if you observe this port 2 side, you have two components, RL and H22. What is RL? Load resistance. To avoid the confusion, let us indicate the V2 and V1 like this. Okay then. Now, yes, we have a resistor RL and another H22. What is H22? Output admittance. Okay. Output admittance and RL are there. So totally what is the resistance the output side? Yes, it is RL in parallel with 1 by H22. Because H22 is admittance, 1 by H22 is the resistance, in parallel with RL is the total output resistance. Okay. Now, what you have to find actually? You have to find the output voltage. And we know V is equal to IR. Here this is the output resistance. Now we have to see what is the output current. Say this from port 2, I2 is going like this. But what you have to get? You have to get the current which is coming like this to this parallel combination. Means the current from this side it is I2 and the current flowing this side is minus I2. Minus I2. Okay. So what is minus I2? See here. If the I2 is like this, what is I2? H21 I1. But here, yes, you have to get the current which is flowing in this direction. It is minus I2. So what is that? Minus H21 I1. Okay. Into. Okay. So this becomes your output voltage. Okay. Simply the resistance at the output side multiplied with the current flowing through that resistance. Yes. Divided by. Now, we have to see what is Vs. What is Vs? Here Vs and V1 are same. What is V1? It is the input voltage, and or you can say it is the voltage at the port 1. Okay. Yes. See here, just you apply KVL here. Simply you apply KVL. Yes. H11 I1. Yes. This is the current. Yes. So it is H11 I1 or I1 into H11 plus. Yes. Another voltage source is there. It is H1 to V2. H1 to V2. Okay. So this is your voltage gain V out by Vs. So now in the question what they ask, the condition for maximum small signal voltage gain. Now we have to see at which values of your H parameters your voltage gain AV becomes maximum. Okay. So now if you observe, the denominator consists of H11 and H12. Okay, to get maximum value of AV, what must be the values of H11 and H12? Obviously, H11 must be 0 and H12 is also 0. When these two are 0, the denominator becomes 0 as numerator is having some value divided by 0 gives infinite, means maximum. Okay, so that is the first condition. Then, yes, H21 as it is in the denominator. As it is in the numerator, what must be Ht1? What must be the value of H21? It must be very high. It must be very high. Okay. And we have another parameter, H22. It is like 1 by H22. Obviously, to have maximum value here, H22 must be 0. So totally, these are the conditions to get maximum voltage gain. Okay. So keep H11 H12 it becomes infinite. Yes. As H21 must be high, then it becomes maximum. H22 must be 0, then it becomes infinite. Okay. So this is the condition to get maximum voltage gain. And if you observe, yes, the options, H11 0, H12 0, H21 very high, H22 0. So this is your answer.